Hi everyone, it's Mr. Baker and today we're going to be looking at electrical devices. So let's start by thinking about the type of electrical power things that we might have used today, the electrical appliances we might have used today. So let's think about the things that might be in your kitchen. So you might have these kinds of things: freezer, fridge, microwave oven, food processor, toaster, maybe a bread maker, kettle, dishwasher. And all of these things are just what we would take for granted as what we would use every day in our kitchen. Now, if we look at that list again, you can see all of the ones down this side of the list have got a heater, and all of these ones here have got a motor. And these are the things, really, the main things that we use electricity for in our kitchen, maybe. That we have things that have got a heater in, or we have things that have got a motor. But you can see already that electricity is starting to become quite versatile. We can see that actually, with a flick of a switch, I can have things that make heat, and I can make things move by just literally flicking a switch. So have a think now, please, about these 5 things. So these are typical things we might use electricity for in our house. So for heating stuff up, for making stuff move, for making light, for cooling things down, and for entertainment. What I'd like you to do is just to pause the video for a second and think about each one of these tasks, and then write down what things that we might do. So for each of these things then, so for each of the 5 tasks, come up with as many ways of doing this task without using electrical energy as possible, and then now come up with advantages and disadvantages for these other methods compared to using electricity, and then put the list into 2 columns: advantages and disadvantages. Okay, so just pause the clip now. So I'm going to move on and I'm going to tell you what I think are the main advantages and disadvantages of using electricity. So if you didn't get these advantages and disadvantages, you might want to jot these ones down. So the 4 main advantages are that there's no pollution at the point of use. So when I flick a switch, I don't get any smoke, I don't get anything coming off, any gases coming off, so there's no pollution when I actually flick a switch. It's really easy to use. I literally have to flick a switch. And it can be used to operate a large variety of domestic appliances, so lots of different types of things. It's very flexible. I can use lots of electricity to power lots and lots of different types of things. And I don't have any problems storing it. I don't have to have a room in my house called the electricity room, and we have all the electricity in there, and I plug stuff in there. I can literally just plug things into a socket in the wall, and then I can use it. I can even charge things up and then take them with me as well. What are the main advantages then? So although there aren't any storage problems, it's really, really difficult to store it as well. So we're at risk if we've got a power cut that we don't have any electricity. It's obviously potentially dangerous. There's a risk of electric shock if we don't use it properly. And we do need cables to our house to actually connect us to the electricity, which is a problem for remote properties. So places that are out in the middle of nowhere in the wilderness, you've still got to have wires that connect you to the electrical systems and to the national grid, so that you can do that. And obviously then if there's high winds or bad weather, that could potentially cut you off as well. So next, for a little bit of revision, hopefully, of power. So power, I don't know if you can remember what power is, but power is the rate at which we transfer energy, the rate at which energy is transferred. And because of this, we use a unit called the watt, and power in watts is the amount of joules transferred in 1 second. Now, you might use a triangle to do this, to work this out. So if I wanted to work out how much power something had, I would be able to cover over P there for power, and then that would be the energy transferred divided by the time taken. If I wanted to find out how much energy is being transferred, it would be the power rating times the time. And if I wanted to find out how long something's been on, if I know the energy and the power, I'd cover over T, and it'd be the energy divided by the power. But our basic definition for power is power equals energy divided by time, or the energy transferred divided by time. And if you can remember, the energy transferred, we also call that the work done as well. So you could have the power It's the work done divided by the time. So this is just our general definition of power, and we've looked at how electrical power can be defined as well. But this is really important when we're looking at the amount of energy that we use with an electrical device. So energy equals the power times the time. And we'll look at why that is important for when we're looking at different units next. Okay, so we've just said that power equals energy divided by time, and energy is measured in joules. So that's fine. Normally, if I'm moving stuff with forces of newtons and I'm moving in meters, it makes sense to use my unit of joules. But electricity isn't quite like that. I can use millions and millions of joules over a couple of months, and actually that wouldn't make any sense for electrical companies to give me this massive long bill, all these zeros on the end of it, which would take up pages and pages, and I'd have to figure out how much energy I've used. So electrical companies use a different unit of electricity, and they use something called units, and they call it, basically 1 unit is 1 kilowatt hour. So to work out how much something would cost, we would use 2 steps. So basically, when you get an electrical bill, maybe every month, every 3 months, you first of all got to find out how much energy you've been using, how many units or how many kilowatt hours you've been using. And then if you know how many units you've used, then you can work out how much it's going to cost. So this is how you do it. So to find out how many units you've used, you would find the power rating of your appliance. So every electrical appliance in your house will have a power rating. So maybe a TV has got a power rating of 50 watts. But first of all, you'd have to convert that into how many kilowatts that is. And then you'd need to multiply that by how long you've had your device on for. So if you've had, let's say, a kettle, which is going to be about 2 kilowatts, and you've had that on for 1 hour over a week, let's say, then you'd have your number of units would be 2 times 1. 2 kilowatts times 1 hour, so our units would be 2 kilowatt hours. So our units there, or our electrical units here, the electrical companies use, would be kilowatt hours. Then what electrical companies do, so they know how much they charge you, basically every unit that you use, they would assign a cost, and that would depend on lots of things. Maybe it would depend on the cost of oil, the price of oil at the time, or whether you'd gone for like a green bill and you said that I'm going to pay a little bit more so that all of my electricity that I'm getting comes from wind turbines or something like that. But let's say that it costs you, say, 15p per unit. So every unit of electricity, electrical energy would cost you 15p. I've just said that we've had 2 kilowatt hours from our kettle on all week, so 2 times 15, so my kettle for a week would cost me 30p, for example. Let's have a look at a few more examples of this. So here we've got an electrical fire here, and let's see, so a 3 kilowatt fire left on for 1 hour, that would use 3 kilowatt hours of energy. Let's have a look at these and see if we can do these. A 1 kilowatt toaster left on for 2 hours, how much would that use? Okay, so that's it. So 1 kilowatt times 2 hours, 1 times 2, that would equal 2 kilowatt hours. A 0.5 kilowatt Hoover left on for 4 hours, that would be 0.5 times 4. So 0.5 times 4, that would be 2 kilowatt hours. How about a TV? A 200 watt TV left on for 5 hours, that would be 200, now here we've got 200 watts, so we've got to convert that into kilowatts. So there's 1,000 watts in a kilowatt, so 200 watts would be 0.2 kilowatts. So we've got 0.2 times 5, so 0.2 kilowatts times 5 would equal 1 kilowatt hours. And then finally, a 2 kilowatt kettle, if that was left on for 15 minutes, how many kilowatt hours would that be? So we've got 2, and that's in kilowatts, so that's okay, but here we've got 15 minutes. So 15 minutes is a quarter of an hour, 0.25 of an hour. So we've got 2 times 0.25, 2 times a quarter, and that would equal 0.5 kilowatt hours. Okay, so hopefully you get the idea for that. Right, so we've described how we can work out the energy transfer in joules using our power equals energy divided by time equation. We've looked at how energy can be measured in things called kilowatt hours and how we can work that out. We've talked about costs a little bit. We've seen how maybe we can convert between the different units as well. And then hopefully some of the tasks that you'll be able to do will help you to do that last objective there as well, to be able to analyse electrical devices and compare their efficiency. Okay, thanks very much. Stay well, Mr. Baker.